Why is the sky blue? This question has been asked by many, including young children and a few of my viewers. So in today's episode of Real Engineering, we're going to find out together why the sky is blue. Sunlight is made up of all the colors of the rainbow. You can see this if you take a prism and put it in a beam of sunlight. The sun's rays will bend as they pass through the prism and separate into a beautiful arc of colors. But sunlight isn't just made up of these colors. It's also made up of all the colors between those lines, which is a continuous spectrum. So technically speaking, sunlight is white because it contains all colors of light. When sunlight hits Earth's surface, some's reflected and scattered back into the atmosphere. Blue light gets scattered more than other colors because it's been bent or scattered around by molecules in Earth's atmosphere. This phenomenon is called Rayleigh scattering, and you can see how it works here. Light moves faster through empty space, like a vacuum, compared to when it moves through matter. When light moves from one medium to another, like from a vacuum into air, its speed changes. And when its speed changes, its direction also changes. This change in direction is called refraction. Rayleigh scattering happens when light is scattered by particles that are much smaller than the wavelength of the light itself, like when sunlight is scattered by molecules in our atmosphere. Molecules in the atmosphere absorb and re-emit light in all directions. This re-emission is what scatters the light and makes the sky blue. It's kind of like taking a tennis ball and throwing it at a bowling ball, and having the bowling ball randomly re-throw the tennis ball in a random re-emission, each direction each time. Here you can see how the tennis ball changes direction after hitting the bowling ball, just like light changes direction when it hits a molecule. Now, the interesting thing about this random re-throwing of the tennis ball is that if the tennis ball was a different color, it wouldn't be re-thrown in a different direction. In other words, if red light hits a molecule, it would still be scattered in all directions, just like blue light. However, blue light is scattered much more than red light. To understand why, let's look at how light waves move. These wiggly lines represent light waves moving through space. As you can see, this light wave has a relatively low frequency and long wavelength. This light wave has a high frequency and short wavelength. Visible light falls somewhere in the middle in terms of frequency and wavelength. The lower the frequency of the light wave, the less it gets affected by molecules in the atmosphere. The higher the frequency, the more it gets affected by molecules in the atmosphere. Since blue light has a higher frequency than red light, it gets scattered more by molecules in the atmosphere. If you want to learn more about how light interacts with matter, check out the video link above. So now you know that the sky is blue because blue light gets scattered more by molecules in the atmosphere than other colors. But there's still one thing we need to explain. Why are the molecules in the atmosphere only scattering blue light and not violet light, which has an even higher frequency and shorter wavelength than blue light? Well, there are two reasons for this. First, our atmosphere doesn't contain enough molecules to scatter violet light. Second, human eyes are more sensitive to blue light than violet light. Let's take a look at the first reason. Our atmosphere is mostly made up of nitrogen and oxygen molecules, and there are about 3 billion molecules per cubic meter of air. That's a lot of molecules. The amount of violet light that gets scattered by these molecules is very small because of how small the cross-section is. You might have heard the term cross-section before when talking about nuclear physics. The cross-section in nuclear physics is the probability of a particle, like a neutron interacting with another particle like a uranium atom. The larger the cross-section, the more likely it is that the two particles will interact. Similarly, the larger the cross-section of light, the more likely it is that it will be scattered by a molecule. As you can see here, the cross-section of violet light is much smaller than the cross-section of blue light. In other words, violet light is much less likely to be scattered by a molecule than blue light. Since there aren't very many molecules in our atmosphere, most of the violet light passes right through without being scattered. Here's the second reason why we see blue skies instead of violet skies. The human eye is more sensitive to blue light than violet light. If you look at a bright blue t-shirt under daylight, it looks blue, right? But if you shine a flashlight on the t-shirt, it doesn't look blue anymore, it looks white. This is because the human eye is more sensitive to blue light than violet light. When you look at something during the day, you're really looking at all the light that's been reflected off the object and scattered into your eye. Most of this light is blue because of Rayleigh scattering, so your brain interprets the blue light as the color of the object. But when you shine a flashlight on an object, you're adding more light to the scene, so you're seeing the true color of the object, which is actually all colors of light. Now that we know why the sky is blue, let's use our knowledge to answer some follow-up questions. Why is the sky darker blue at noon than it is in the early morning or late afternoon? The intensity of blue light in the sky depends on how many molecules of gas are in the way. The fewer molecules in the way, the less blue light gets scattered, and the lighter the sky will be. At noon, the sun is directly overhead, so the light from the sun passes through less atmosphere than it does in the morning or afternoon. When the sun is lower on the horizon, in fact, when the sun is lower on the horizon, the light from the sun passes through so much atmosphere that most of the blue light gets scattered away, leaving mostly the red and orange colors to reach our eyes, which is why sunrises and sunsets are red and orange. If Earth didn't have an atmosphere, would the sky still be blue? No. Without an atmosphere, there would be no molecules to scatter the sunlight, and the sky would appear black. In fact, if you look up at the sky on a clear night, you'll see that the sky is filled with stars. But if you look at the sky during the day, you'll never see any stars. This is because the sunlight is so bright that you can't see the stars. But when the sun sets, the brightness of the sky decreases dramatically, allowing you to see the stars. The reason for this dramatic decrease in brightness is because of the atmosphere. When the sun is shining, light bounces and scatters everywhere in the atmosphere, making the sky bright. But when the sun sets, the sky becomes dark because most of the light passes through the atmosphere unscattered. What about those airplanes and jets that leave contrails behind? Those trails aren't contrails, and they're called cirrus clouds. Cirrus clouds are made up of ice crystals that form in the cold upper atmosphere. Ice crystals are much larger than molecules, so they scatter all colors of light equally. So what do contrails look like? Contrails don't look like a line behind the airplane. They actually look like a cone behind the airplane. Here you can see a contrail starting as a cone behind the airplane. As the airplane continues flying, the contrail forms a thin sheet behind the plane, because the gases in the atmosphere expand as the pressure decreases. Why is the sky blue on exoplanets? We don't know. It depends on what the atmosphere of the planet is made up of and how much of each color of light it scatters. For example, if a planet had a thick atmosphere made up of methane, the sky could be green. Scientists think that the sky of Saturn's moon Titan is green because of the methane in its atmosphere. If you enjoyed this video, check out my video about why the sky is black at night. I hope you learned something. If you did, hit that thumbs up button below. If you haven't subscribed yet, hit that subscribe button. And if you know someone who could use some engineering in their life, share this video with them. Thanks for watching.